Good afternoon and Happy New Year, everyone. Welcome to our first CIC Power Talk in 2022. My name is Thomas. I'm sure most of you guys knowing that we organized the first CIC Construction Digitalization Award in November last year. In today's Power Talk, it is our honor to invite the Gold Award winners of the project categories Causeway Link, 將軍澳 Main Bridge and associated works to share with us. Let me quickly introduce our honorable guest today. The one sit right at the middle is the representative from the project clients, Engineer Michael Leung, Project Managers East, Civil Engineering and Development Department. The one sit right next to me is the representative from the consultant, Dr. Robin Sum, Director, Global Longspan and Specialty Bridges from AECOM. And the guests from the far side is the representative from the contractors, Engineer Wong Yen Hua, Managing Director, China Road and Bridge Corporations, Hong Kong. I know that Causeway Link has just reached a milestone at the end of last year. Michael, would you mind to share with us a little bit more about this good news? Please, Michael.
Thank you. A couple of slides to show the background of this project. The project team, first of all, of Causeway Link, wishes everybody good health, happiness, all the best, and best of business in the new year. I'm delighted to step into this new year at work with my partners, Robin on my side and Engineer Wang on the other side. As Thomas highlighted, at the end of last year, the Causeway Link has reached an important milestone, namely the main line has connected to the將軍澳Lam-Tin Tunnel. Now, we have got a small video to show this.
Congratulations to the team to achieve such a remarkable milestone. I'm sure the audience would like to know more about the project. Michael, would you mind to tell us a bit more about why do we need this Causeway Link and what are the scopes of this project?
Pleased to do that. This is the alignment of Route 6 and Causeway Link. The trunk road is of 14.5 kilometers, a total cost of 80 billion. The central current road between Yau Ma Tei and Kai Tak is delivered by Highways Department. CDD, ECO is delivering the rest of the trunk road of a total length of 10 kilometers, a total cost of 40 million. The whole Route 6 is expected to be commissioned by 2026. So let's turn our focus on our key masterpiece today, the Causeway Link. With further development of將軍澳 New Town, the traffic demand is expected to grow. Causeway Link will provide an alternative access route to the southeast part of將軍澳, thereby enhancing the road connection network of the area. Upon completion of將軍澳Lam-Tin Tunnel and Causeway Link this year, coming from the southeast part of将軍澳, you commute to and from the western part of将軍澳via Cross Bay Link, or commute to and from Kowloon East via將軍澳London Tunnel. And journey time during peak hour is expected to be squeezed substantially, but reduced by about 20 minutes. Now, Cross Bay Link is of a length of 1.8 kilometers. It includes a 1 kilometer long marine viaduct across Jung Bay. It comprises extensive prefabrication steel and construction steel members. It is the first multi-purpose marine viaduct in Hong Kong. It composed of a dual carriageway, cycle track, and footway, 3 in 1. The cycle track and footway will connect to the existing將軍澳promenade. It forms a 5 kilometers waterfront loop for the public to enjoy. The marine viaduct consists of 3 steel decks, namely the thematic double arch steel deck in the middle, 2 side spans, and 34 stay cables. The length of the central steel deck is 200 meters, and by far the longest arch bridge in Hong Kong. The weight is around 10,000 tons, equivalent to the weight of 50 Boeing 747 Airjet. Thank you. This is the background of the Cross Bay Link project.
Thank you, Michael. Michael, I know the project has tailor-made an electronic site inspection system. Do you mind to tell us a bit more, why are you using it and what the benefit of using this inspection system?
Nowadays, a digital works supervision system, DWSS, is essential for major projects. It's essentially a web-based portal of collecting works information and managing workflows to enhance efficiency, safety, and quality. CPL is the pilot project adopting the idea of DWSS to promote efficiency and work performance. The project team has developed from day one an electronic system named Electronic Site Inspection System, ESIS, in 中文公檢通, as early as 2019. ESIS is a well-organized central platform promoting paperless delivery. Up to this date, about 10,000 e-forms was submitted and processed by the project team. The submitted log of each and every form is traceable and logged. It reduces time on administrative work and eliminates human errors. It's accessible by desktop and laptop computers, as well as mobile device. To ensure data security, all e-forms are stored in servers and regularly updated and synchronized with the clock of the Hong Kong Observatory. All data is retrievable and searchable. It helps to enhance the efficiency of project delivery. Thank you.
Thank you, Michael. I think we have got an outlook of how this electronic system works. And I also know that the Cross Bay Link is the first and the only major bridges in Hong Kong adopting a full digitalized design with the FMA and prefabricated design concept. Michael, do you mind tell us a bit more what are the challenges of using all these digitizations, tool, and what the expectations from CEDD to your contractors, and how all these digital tools can be used to really solve the engineering challenge we face on the project?
As a client, CEDD attaches importance on using digital tools in early planning stage to promote the industry standard of the industry. So we specify the use of digital tools such as BIM as the essential requirement in the tender documents. So the project team will be fully prepared before work commencement. We fully appreciate that frontline staff, be it contractor or consultant, may not be familiar for the use of digital tools. So the successful promotion of such tools, we stress on user-friendliness and key, as well as buy-ins. They're all key elements to its success. For example, at the development stage of ESRS Gong Kim Tong, the project team studied the entire process of submission and review, and coordinated with our frontline staff, namely RSS and contractor, on how to streamline the process and help to improve efficiency. Not to say continuous review and sufficient training are essential for a successful promotion. Thank you.
Michael, thank you so much. Thank you for your valuable sharing on the background and how the digital tools has been used on this project. Thank you so much. And I know that the design concept of this bridge is a core like eternity arch, which symbolizes the vibrance coupled with infinity development potentials of Jiangguan O, was adopted in the Cross Bay Link project. The aesthetic design of the main bridges is unique and elegant, which is in a good harmonies with a surrounding environment. I believe, Robin, you as the consultant of the project, I'm sure you can share a bit more to the audience. What are the design concept behind it, and what are the project feature, and how all these features can be incorporated in such a challenging project? Thank you, Robin.
Yeah, sure, Thomas. Are you sitting comfortably? Now I begin. In my younger days, there was a very famous movie called A Bridge Too Far. That gave me tremendous inspiration all my life. I've done a lot of projects in my time, but when I come to Cross Bay Link, I really think it's special. This is a project where raw talent meets the power of digitization. The end result is there's no bridge too far. Now, we give the people of Hong Kong this family of bridges, and we give this family of bridges to the world as well. Why am I mentioning that? Because both your Cross Bay Link and your future Southern Bridge in the foreground are all delivered by the same team, CDD, ECOM, and CRBC. Now, you're looking across the Victoria Harbour towards Hong Kong Island. This is stunning, Cross Bay Link. On the west side, the Marine Viaduct 3-span, the east side 6-span, and the centerpiece of the project is the Eternity Arch, a total 400-meter span. Let us take you through some of the key features and special. Okay. The two arch ribs, they incline outward, and they seem to disappear, or I would say they merge seamlessly with the deck girder. So the end result is kind of like the mathematical symbol of infinity. And that, to many people, it personifies the very best, the vision, energy, and eternity of the people. That you can see the infinity symbol. Of course, we study the wind climate, in order to design this bridge. And at the girder level, the design wind speed is 89 meters per second, and at the crown, at the top of the arch, it's 97 meters per second. Now you can see a driver's view. You look at the cross section of the deck. It's asymmetrical. And also the bridge furnitures, they are different. Of course, they're not symmetrical, they're different. So that poses a lot of very interesting aerodynamic problems to be resolved.
Thank you, Robin. I see that infinity or eternity arches also looks like the icon for a technology company. They recently rebranded themselves as a Meta. Yes, so it looks like quite similar shape. Robin, do you mind to also describe a bit more on what are the innovative ideas you have adopted to develop this project, to make sure this project has been delivered successfully?
Okay, step number one. Any design we do, we think about construction. So I like the phrase, we integrate design with construction, because we already built into our analysis and design construction method and sequence. May I tell you more? So up front, we were thinking about how exactly the bridge can be built. So for the Eternity Arch, one method is to lift it by a barge crane. And we look at the availability and different types of barge crane in the Asia region. And as you know, during lifting, the load paths and the stresses, they are quite different from the permanent condition. So if this method is adopted, we have to do the analysis and creative design very carefully and meticulously. Now, again, in my young days, I had a lot of toys built in Lego bricks. By the way, I still do. I still have them. So I asked myself, how best to achieve quality, fast track, and competitive pricing? Why can't we build that bridge like Lego bricks? That's exactly how it was built. And of course, we built that into our design. Yeah. And let's look at some of the optimization we've done. When we started, the first thing that came to mind would be a trapezoidal box, with solid diaphragms. We changed all that. You see the diaphragm, the solid diaphragm, been replaced by space trusses, so lightweight. And this is the first time in Hong Kong, that's been done. Yeah, and we replaced the single trapezoidal box by a twin box, so it further reduces the weight of the structure. Yeah, and for the arch width, we adopted high strength steel, 690 grade. Why would we want to do that? Because the stresses are quite high at the swinging. And one thing we always endeavor to do is to reduce the carbon footprint of our design. So using the 690 high strength steel, we managed to reduce the carbon footprint by around 40%. Okay, so you can see the twin box there, as I mentioned earlier. I mentioned that there have been some very interesting and challenging, aerodynamic problems. So we've done a series of wind tunnel tests. What you see here, it's a section model test. That's yours truly in the wind tunnel with the section model. Yeah, and you can see the model cars, and in the foreground, you see the planter and the isolation panel. Why would we have an isolation panel? Because this is a living bridge for commuters, as well as and also for leisure activities. So we have transparent solid panel segregating the live carriageway and the footway and cycle track. So that itself poses a lot of aerodynamic challenges. Here's another series of section model tests, this time in Nantes, in France. You can see the vehicles on one side, and this is a blown-up view. You can see the planter, the segregation panel, and in fact, I believe the video has started, but the wind speed in the tunnel is just increasing. So you can hardly see the motions. Later, you will see a little bit of motion. And in all tests, we keep increasing the wind speed to push and to investigate, at what point, the design might become unstable. Sometimes, of course, we have to stop. We come to our senses, because we don't want to break the model. So when we see it surpass the design wind speed for instability, we stop. This is, again, an earlier version of the design. You see the two edges of the girder, of the deck girder. We have cantilever wings. And that combination, that geometry and configuration, combined with the segregation isolation panel, gave us a lot of vortex oscillation problems. So we designed sometime by experiment. So we found if we close up the underside cantilever wings, as you can see here in red, we close it off, and then we were experimenting with closing off the bottom, the soffit, and reconfiguring the bridge furniture, and we found, closing off the underside cantilever wing, that resolved the problem. And then Michael and I went to the largest civil engineering wind tunnels in the world. That was in Chengdu, and we tested this our elastic model. In this set of wind tunnel tests, we found 0.5, 0.5% of critical damping suppressed the vibration of the girder, and then 0.3% suppressed the vibration of the arch ribs. So that gave us data for the damper design. Originally, this photo was for the benefit of my boss to show I was actually working. But fortunately, Michael was there. So Michael confirmed, Robin actually been working hard. So with wind tunnel results and also by dynamic analysis, we design and later install a number of twin mass dampers for suppression. Now this is a view of the marine viaduct whole span lifting method. How fast track can you be if you lift the whole span? Okay, so the 18 number lifting operations. Okay, and the design in the precasting yard, we stress the bottom flange, the web, and then we transversely stress the top flange. And the girder at that point is self-stable, and the stresses, they are adequate for lifting. Now this is on site. On site, we complete the stressing operation. Yeah, and to give you a bit more detail, now, a lot of us design to British standard. So intuitively, you design the girder longitudinally as a pre-stress structure and transversely as reinforced. I worked in Western Europe, and they actually use transverse pre-stress. And then a colleague of mine, he gained his experience from Japan. So he also, he can apply that technology for durability and for transversely spending larger distance. Now this is the articulation we use we minimize the number of expansion joints to improve riding comfort. And we use friction pendulum bearings, a combination of that and elastomeric bearings. Firstly, to achieve a seismic resilient design, and also to reduce the longitudinal movement. Here, different views, the architectural lighting is computer controlled. Thank you. Now, a picture is worth 1,000 words. We have filmed on location the erection of the Eternity Arch. Please enjoy.
Robin, thank you so much. Thanks for sharing of all these innovative ideas and all the technologies or technical details, how you develop such a challenging bridges design. And I'm sure Causeway Link will definitely be the new icon of将軍澳. And I know that Causeway Link has achieved of many firsts in Hong Kong construction industry during the delivery of this project. So I think it would be nice to have engineering Wongs here to tell us a bit more how you have utilized all these digitalization tools and how you use those tools to optimize the construction's delivery of these projects. Engineering Wong, please let us know a bit more detail. Thank you.
Thank you, Thomas. Ladies and gentlemen, it's my great honor to be here to share with you on the construction digitalizations for this iconic bridge. In delivering these projects, we have achieved many firsts in Hong Kong construction industries. The first time, we used the flow-over method to install the full-span butterfly bridge with weight of about 12,000 in ton in Hong Kong, including temporary works. It's first time to use full-span lifting method to install the pre-stressed concrete box girders in Hong Kong with weight of about 3,300 tons and a length of 75 meters. It's first time to fabricate grade S690 high-strength steel for the bridges. To go for the digitalizations, the key is to change the mindset. By changing the mindset from the traditional to the digital, we have achieved better collaborations and coordinations among all stakeholders, which we found and improved to be the fundamental for the successful delivery of these projects. On these projects, we adopt many digital tools, including the big data, the BIM, the 3D survey, and also IoTs, robotics, and automations in the constructions. From the beginning of the projects, we have formulated the strategies for applying the construction digitalizations on these contracts. Our digitalization structure covers 6 aspects, which include the digital design and plannings, the digital management platforms, robotic constructions, DFMA with digital tools, digital work supervision supervision system, digital twin, and 3D surveys. VR 3D CM platforms is a comprehensive management platform which supports the visualizations of the 3D GIS and the BIM in one integrated viewers for users. Our digital platforms include 4 modules, which are planning and designs, photo management, 3D data management, and deformation management. On these contracts, the BIM model was integrated with GIS information such that it could be displayed and manipulated with great geographic details. Site photos could be displayed and also filtered according to their locations. IoT monitoring sensors which monitor the site environments and also integrate with centralized platforms. Construction BIM models in LD400 was developed for improving the constructions. We use the BIM to carry out the clash analysis and detections to verify the buildabilities and compatibilities. We use the BIM to simulate the construction method and the sequence. We also use the BIMs to generate the design drawings, shop drawings, and also combined service drawings. We also use the BIMs to formulate the walkthrough videos. Digitalizing technology is also used for the fabrications of the steel arch bridge and the steel side spans. With the adoption of the highly developed BIM models, the fabrication of a steel bridge becomes digitalized throughout the whole production process in a more effective and efficient manner, which this process of fabrications, such as design, such as the shop drawing productions, the weldings, sub-assemblies, and assemblies are all integrated in BIM-based platforms. By using the 3D laser scanner and digital photographic technologies, we can carry out pre-virtual assemblies for the fabrications of the steel bridges before the real assembly is carried out. Yes, we also applied the 3D digital surveys on these projects. So this 3D digital technology was adopted for reality data capturing, which include UAV photogrammetries, UAV photo taking and processing, and 3D laser scannings. This 3D digital survey makes surveys more safe, more accessible, more cost-effective and efficient, while achieving sufficient accuracy. The rapid speed of the data capture from a 3D laser scanner allows millions of data points to be recorded in just a second. The image here shows the comparisons of the laser scanning data with the BIM models. You can see even minor difference in the geometry of the SBO bridge could be identified when comparing its laser scanning data with the design values in the BIM models. On these projects, we also apply and adopt DFMA technology from the substructure to the superstructure of the bridge, which include DFMA for the precast shell of the power cap, DFMA for the precast V pier and also straight piers, DFMA for the precast segments and precast box girders. The digital twin was also applied throughout the whole process of the DFMA, from the initial planning and design until the off-site fabrication and on-site installations. During the design of the DFMA elements, BIM was used to simulate the whole construction process in a virtual world to verify their buildabilities, to schedule the program plannings, and also estimate the savings in both the material and the carbon footprints. From the photos here, you can see even the details such as rebar details, connection details, and also the vessel deployment plan can be studied in advance before they actually implemented. We also applied DFMA for the steel arch bridge constructions. The steel arch bridge was fabricated and fully assembled in the off-site yard in Nantong, Jiangsu province. After being loaded out to a delivery barge, it was transported to Hong Kong by a semi-submersible barge, and then installed on the pier by flow-over method. This method makes use of tie and also the ballasting of the semi-submersible barge. With this method, we complete the whole installation process in just 5 hours. Digital work supervision system also adopted on these projects, which has enabled the project team to better control and monitor the off-site fabrications in efficient and effective ways. This DWSS system is capable of creating the list of tasks timely, assigning the task to the teammate, and analyzing the collected data automatically. We adopt these systems both on-site in Hong Kong and also off-site in mainland China. Productivity of the inspection is increased by 80% thanks to the application of this DWSS. On these projects, we also adopt many robotics for the construction activities. Here is some examples. We have used hydro-demolition robot named aquajet cutters to trim the power head of the ball pile, which offers benefit such as low dust and noise, less number of workers compared with the traditional method. In addition, we also use robotic breaker to work together in combination with the aquajet cutters in trimming the power head. All those robots was remotely controlled with great enhancement of the safeties. For the fabrication of the steel bridge, we also adopt a number of welding robots. This welding robot was used to fabricate the U-ribs and diaphragms of the steel bridge. It has been proved that this welding robot is very reliable and efficient than the conventional welding machines, especially for those inaccessible locations and those complicated and precise weld. For construction of a box girder, we also developed a formwork removal robot, which is used for stripping the inner formwork of box girders. This robot was equipped with hydraulic piston to retract internal formwork from inside the box cell. We found this robot is very efficient and effective when working in a congested space like box girder cell. And most important, we found this robot can substantially improve the site safeties. Thank you.
Thank you, Engineering Wong. It's so impressive. You literally help us to redefine how the modern bridges should be built like this. And I must say that without courage, visions, and the collaboration mindset between all of you, I don't think we can deliver such a successful project. And it also become a showcase for the whole world about what the modern bridges can be built. I've got a questions I would like to ask all three of you. It's about what's your view on how the digitalizations will change our construction industry. So let me ask my friend sitting right next to me, Robin, what's your view on that?
To me, digitization actually opens up new horizons in the construction industry. Of course, the industry got no shortage of talents, but the bar is set higher and higher with this new technology, and the talented people, they have more tools or more suitable tools for them to aim high and achieve more. Closer to home, we have a digital technology team in the e-com, and we can give them all sorts of praises, compliments, but I think what personifies their success is they help us to unlock our own talents. In our creative design, with the help of digital technology, we can experiment, we can visualize different shapes, form, profile, different shades. Earlier, I talked about integrating design with construction. With digital technology, we can do virtual erection sequence, methods and sequence. Like the sky's the limit, as Mr. Wang, taken you through, the floating method of erection for the eternity of arch, that has been through meticulous calculation every step of the way in the sea voyage, the jacking down, 3D jacking control, everything. And I think it really, the sky's the limit.
Thank you, Robin. So I'm looking forward to see your next masterpiece, yes? It will be something even more interesting bridges coming up very soon, I'm sure. And how about Engineer Wong? What's your view on this? How the digitalization could change our construction industry?
Yes, the digitalization actually changed our construction industry substantially. I believe with the digitalization, our construction industry will be transformed into intelligentizations, informatizations, and automations. We are engineers will no more be Depon Lao, will be more professional. We can do all the things, even just from the phones, just in front of the computers. So I looking forward, more change will be happened. Thank you.
Thank you. I'm sure the industry seeing you guys, how you demonstrate, how it actually works. It really pushes us to the limit. The limit will be the sky, right? And last but not least, I would like to ask Michael, is the key man, how to drive this project deliver so successfully. What's your view on this? And can you also please give us the roundup of today's sharing sessions? Thank you, Michael.
2 slides to summarize my observation. With increasing project difficulty and complexity, innovative technology are the key to stay, to solving our challenges. And CDD has implemented our departmental strategic plan. One key initiative being, quote, welcome and accept change and embrace innovation, unquote. To improve performance in aspects of quality, safety, environment, time and cost, we encourage our partners to adopt continuously, new technologies to enhance the industry standard and to realize the goals stated in Construction 2.0, our vision. And in John's hands, the project team is taking forward the cross-building in full steam to have it completed and commissioned this year. Thank you.
Thank you, Michael. Thank you so much for the sharing from all the speakers today. And now may I take this opportunity to do some promotions for CIC. Construction's Innovation Expo 2022 and Construction Industry Council Innovation Award. The triennial flagship event of the construction industry, Construction Innovation Expo 2022 and Construction Innovation Award 2022 have been kicked off. CI Expos will be held from the 12th to 16th December 2022 at the Hong Kong Convention Center, showcasing the innovative construction solutions and technologies, providing an effective platform for business development. Please register a booth now. On the other hand, the Construction Industry Council Innovation Award is now open for submissions. The total prize money exceeds 2.5 million Hong Kong dollar. Please visit our website, cic.hk, for more detail. Construction Innovation and Technology Fund, CITF, was established in October 2018, and now it has been enhanced under the new enhancement measures effective on the 1st of January. Each company can enjoy a fund ceiling of up to 6 million Hong Kong dollars under the BIM and Advanced Construction Technologies categories. Please refer to our CITF website for further information. There are free online BIM viewer training. To cope with the surge demand of BIM viewers, CIC developed a teaching and learning kit for BIM viewers training. After completing the trainings through self-learning and taught courses, practitioners could participate in an online quiz and able to obtain a BIM viewer certificate. Please scan the QR code for detail. Construction industry sports and volunteering programs and annual CISVP Corporate Award for Activeness. With a view of promoting a healthy lifestyle and caring culture in the construction industry, CIC set up the Construction Industry Sports and Volunteering Program, CISVP. I know many industry stakeholders like to promote the corporate social responsibilities and organize different volunteer activities. The annual CISVP Corporate Award for Activeness deadline is on the 28th of January. Please do apply now. I hope all of you enjoyed today's Power Talk, and thank you so much for all the honorable guests and all of you attending these webinars, and we wish you all have a pleasant evening. Goodbye.